Good morning. So today's class I am going to have some easier way of computing shear force and bending moment in beams for the third semester mechanics of structures as a easy tip for your exam. Okay, I'll discuss 2 or 3 numerical examples from cantilever beam, simply supported beam and beam with overhang. The first one I am going to deal with cantilever beam. So figure shows a cantilever beam. A cantilever means one end fixed and the other end is free. So this end A is fixed and the other end is free, and it is subjected to point loads or concentrated loads 800, 500, 300 Newton respectively, and the results are also shown. So you know what is shear force and bending moment. Shear force is nothing but algebraic sum of all the forces acting on one side of a section. If you cut the beam at one particular point or a particular section, consider right of the section. Add up the forces, vertical forces algebraically. That will give you the shear force. Bending moment. It is moment, if you consider a particular section, take moment of all the forces acting on one side of the section. In the case of cantilever beam, I am always going to consider the right side. I am starting from the free end D and then I will proceed in this direction. Okay, and there is sign convention to draw the shear force diagram and bending moment diagram. The sign convention is, if you consider a section XX, all the forces acting to the left of the section, if you consider left side of section, forces acting upward should be taken as positive. If you consider right side of the section, forces acting downward should be taken as positive. So just now remember, I am going to give how to calculate the shear forces. First of all, we will deal with that. The sign convention is, if you consider a section, right of section, downward forces positive. So I am going to write it in very fast. I will consider first this portion CD. I am going to take a section here in this portion. You consider right of it. What are the forces? There is only one force, 800 Newton. You consider a section in that portion. You consider right of that. There is only one force, 800 Newton. So I can write shear force at D, FD, is equal to 800 Newton. What about the sign? That force is acting downward. So right of the section, downward force positive. So this is plus 800 Newton. Now, if the section is moved up to here, say up to just to the right of C, just to the right of C, if you consider there is only one force, 800 Newton. But when you move just to the left of C, when you come here, if you take a section here, what will be the total force? It will be 800 plus 500. So, when there is a point load acting at a particular point, you have to write, if you consider the shear force at C, I have to write FC right at the point where there is a point load. FC right, just to the right of C, there is only this 800. Downward force, so positive. But when we consider just to the left, FC left, just to the left of C, there will be two forces, 800 plus 500, so it will be 1300 Newton. Sign is positive because both the forces are acting downwards. Come to the point B, just to the right of B, there are 800 plus 500, 1300. But when we move this side, the force will become 800 plus 500 plus 300. So, shear force at B, I have to write FB right. Just to the right of B, there is 800 plus 500, 1300. We have already written here. And FB left. FB left will be this 800 plus 500 plus another 300. So it will be 1600. Okay, now we consider A at this point A, and you consider 800 plus 500 plus 300. So shear force at A, FA is 1600 Newton. So this is all the shear force calculation. Now we have to draw the diagram. Shear force diagram means a diagram which represents the values of the shear force. That will be taken as the ordinate, y-ordinate, and x-axis will be the length of the beam. So we draw a horizontal line. If the values are positive, you draw it above the line. If the values are negative, you draw it below the line. So here consider first point D. Shear force at D 800. So from this baseline approximately you mark 800. Say this point is 800 meter above this. This is 800. You have to put the unit also there. Very important, 800 Newton. Now coming to FC right, 800. So at this point C, also you mark 800. Join these together. Then FC left 1300. So at this point C, again you mark from the baseline 1300. Next, FB right 1300. At the point B, you mark 1300. From here to here 1300. So just connect them. Then at the point B, again you mark 1600. So here from here you mark 1600. Connect it. At the point A, 1600. So this is 1600 from the base. So this is called the shear force diagram. So by drawing this, we can see that wherever there is point load, here see, it is 800, so this vertical ordinate will be 800. Here there is a load 500, so this much value, this ordinate will be 1300 minus 800, 500. This is going to be 500. Here it is 300, so this ordinate 1300 minus 1600 minus 1300 is 300. Here it is 1600, that I am not going to discuss now, that will require some more concept. Actually 3 plus 5 plus 8, 6600 is the total load. That load will be the reaction at this support. This reaction at this support, vertical reaction will be 1600. So there is a vertical line 1600. That is this. If you don't understand that, doesn't matter. So shear force diagram is nothing but algebraically add the vertical forces. In the cantilever beam, start from the free edge. Download load is positive, so you have marked 800 above the line. When there is no load, so some two more tips we will get from here is, wherever there is point load, the vertical ordinate will be of that value, and when there is no load, it will be going straight parallel to the horizontal axis. So if in this portion there is no load, so a horizontal line parallel to this baseline. There is a load 500, so suddenly it rises up by 500. There is no load, so it goes horizontally. There is a point load 300, so it suddenly rises up by 300. There is no load, so it goes horizontally. This is the two tips now we have got from the shear force diagram. Wherever there is point load, the shear force diagram has a vertical ordinate of that particular magnitude. When there is no load in that portion, the shear force diagram will be a horizontal line parallel to the baseline. Now you hatch the inside. This is the inside of the diagram. You hatch the inside and write positive and write shear force diagram. So with that we have completed the first step, how to compute the shear force and how to draw the diagram. Next we will pass on to how to draw the bending moment diagram. So you have to compute bending moment values and then draw the diagram. So now I am going to discuss how to compute bending moment. That is step 2. So the definition of bending moment is load into distance, force into perpendicular distance is called the bending moment. And sign convention for bending moment is, if you consider right side of a section, we are always coming from right side of a section anti-clockwise moment positive, and vice versa. If you consider left side of section, clockwise positive. Say a moment like this, which tends to bend the beam downwards. So this tends to bend the beam like this. This is called sagging moment. So sagging moment positive is the sign convention followed by us. That is, right of a section anti-clockwise positive. It tends to bend the beam downward. If right side anti-clockwise, just reverse, left side it will be clockwise. Now cantilever beams you always consider right side. Okay. Now at the starting point D, MD, bending moment at D, M suffix D, that is equal to load into distance. That load is acting at that particular point D, distance is 0. So the bending moment at the free end is always 0. Always remember, the bending moment at the free end of a cantilever is 0. Next point C, coming to point C, bending moment at C, MC is equal to, consider just to the right of it, there is only one load, 800. It is acting at a distance of 0.8 meter. So bending moment at C is equal to load into distance. That load is 800 and it is acting at a distance of 0.8. So it is 640. Unit is Newton meter. Newton is the force, meter is the distance. Product of force into distance. What about the sign? To find the sign, see this load 800 is acting like this. You have to take moment about this. So place your thumb or pen like this, rotate it about this point C. Place your thumb like this, rotate it about point C. Your thumb goes in this direction, clockwise direction. So the moment is clockwise. So as per our sign convention, it is negative. 800, rotate about C, it produces a clockwise moment. But we are considering right hand side, anti-clockwise is a positive moment. So this is minus 640. Coming to point B, bending moment at B, MB, consider point B, consider right side of it. There are two loads. This 800 Newton is acting at 0.8 plus 0.7, 1.5 meter. From the point B, 800 Newton is acting at 1.5 meter. So 800 into 1.5. It's producing clockwise moment, so it is minus. Then this 500 Newton, this is acting at 0.7 meter. So that is also produces clockwise moment. So minus 500 into 0.7. These two together works out to 1550. Coming to point A, bending moment at A, MA is equal to, consider point A, right side of it, 1, 2, 3 loads. The first load 800, it's acting at a distance 0.8 plus 0.7, 1.5 plus 0.5, 2 meters. It produces clockwise moment, so I have written negative. The second load 500, acting at a distance 0.7 plus 0.5, 1.2 meter. That also produces clockwise moment. So minus 500 into 1.2. This 300, it is acting at a distance 0.5. So minus 300 into 0.5. It works out to minus of 2350 Newton meter. So that's all. Bending moment calculation is load into distance. At the free ends, the moment is 0. MC is equal to 800 into 0.8. It is negative because it is clockwise moment. So minus 800 into 0.8. At the point B, 800 into the distance 1.5, 500 into 0.7. Similarly at point A. Now we have to draw the diagram. For that, we extend this. Always leave the space below the load diagram. The beam with the given load. Otherwise, you have to reproduce it and you have to draw the bending moment diagram and shear force diagram just below that. You should not draw the diagrams alone. That has no meaning at all. Draw the diagram of beam with the given loading. Below, extend that load lines and support lines, and below that only you draw the bending moment diagram as well as shear force diagram. So you have to start with, you have to draw a baseline. Draw a baseline. with reference to that first point MD 0. So at this point 0. Second, MC minus 640. So you have to draw 640 Newton meter to some scale below the line. So this is 640. Right, the unit is very important, Newton meter. And connect it. Then there are only point loads, connect them by straight line. So connect these two by a straight line. Next is 1550 at MB. At this point B, from here you mark 1550. This is 1550. Connect it by a straight line. Next, at A it is 2350. So from here you mark 2350. All these are straight lines. So this is straight line. So when there is only point load, the bending moment diagram, the ordinates has to be connected by means of straight lines. Then hash the inside. This is negative because all the values are negative values. Write down here bending moment diagram. So this is point A, point B, point C, point D. Hope it is clear to you. So next problem I will deal with mixing up of loads. There are several loads, not only point loads, there will be some uniformly distributed load also.